So we're going to be looking at the guide for the area quiz coming up. And it's over the four basic shapes: parallelogram, rectangle, triangle, and trapezoid are the four rather, main focuses, although a parallelogram and a rectangle are kind of done the same way. So we'll start with the first one here, which is a triangle. We have 7, 6, 5, and 10 feet labeled on the respective sides. But remember, when we're finding the area, we don't necessarily need to use every single measurement given. There's a lot of extra information here we don't need. And so if remember, for a triangle, the area formula for a triangle is base times height, all divided by 2. Remember, if the shape starts with a T, you divide it by 2. So triangles and trapezoids are both divided by 2. Think T for 2, T for triangle, T for trapezoid. So in this case, the only two numbers we really need are the 5 and the 10. Because 5 is the height, because height is normally the dotted line down the middle of the shape or on the side. And then whatever line the height connects to, that's designated as the base. So in this case, I would do a base of 10 times a height of 5 all over 2. Doing some quick math here, 10 times 5 is 50 all over 2. And 50 divided by 2 is a nice even 25. And that'd be feet squared. Notice how it's feet squared, not the number itself squared. So it's not 25 squared, it's 25 square feet, which when taken literally means I can fit 25 1 foot by 1 foot squares inside that triangle. That's why we call it square feet. But that's how we do a triangle. It's multiply and divide. It's not a very long shape at all. Number 2 is a parallelogram, and a parallelogram's formula is even easier. The parallelogram formula is A equals base times height. No dividing by 2 for a parallelogram because it doesn't start with a T. So in this case here, what we're going to do is we're going to take the base, which in this case is 2.5, and the height, which in this case is 1.8. Notice again, we are not using the 2 because the 2 is not inside the shape. Plus, it is not a base because it is not connected inside, or sorry, it's not connected by the height. So the only two lines here that are connected are the 1.8 and the 2.5 in terms of base and height. So we do 2.5 times 1.8. Doing some quick arithmetic there gives you about 4.5 meters squared. And there's our area. So a parallelogram is even quicker than a triangle because you don't have to divide by 2. This trapezoid one, though, is probably one of the longer ones. Trapezoid is probably the longest shape in terms of area that we have, in terms of the steps involved. So for a trapezoid, the formula looks like this. A equals base 1 plus base 2 divided by 2 and all times the height. So what do base 1 and base 2 mean? Base 1 and base 2 simply means top and bottom. So base 1 is the top, base 2 is the bottom. Or put another way, they are the two lines that are connected by the height. So in a trapezoid, the height is going to connect two different segments. Base 1, which is usually the top, and base 2, which is usually the bottom. Again, it could go side to side technically if the trapezoid is turned around, but usually it's top and bottom. And the height, as always, is that dotted line on the inside or outside the shape telling you how tall it is. And the reason we're dividing it by 2 here, and there's a long reason, but you can kind of think of it as a trapezoid is basically a triangle with the head cut off. So in this case here, we still have some remnants of the triangle formula, which in this case is the divide by 2 part. So that's why we have that still divide by 2 in there, because a trapezoid and triangle are very closely related in that regard. So let's figure this out here. So what are base 1 and base 2? Well, I know that 4 is my height, so that right there is my h. Which means the two lines that are connected by the height are the two lines that are base 1 and base 2. So 6 would be base 1, which is the top, and 8 would be base 2, which is the bottom. Notice again, I'm not going to use the 7, I'm not going to use the 5, because they do not involve the area of this. So here we go. Base 1, 6, plus base 2, 8, divided by 2, all times my height, which is 4. Again, doing some quick math here, 6 plus 8, well, that's going to give me 14, divided by 2, all times 4. And then that's going to give me 7, all times 4, which will give me 28, and then it would be units squared if you want to label it, or square units as it would be said. So it's probably one of the longer ones. It has 1, 2, 3 steps in total, depending on how you count them. But it's still a very succinct formula. It's still very step by step. Add, divide by 2, multiply. And technically speaking, you can either divide by 2 first and then multiply by height, or you can multiply by height and then divide by 2 first. It really doesn't matter. Usually, as long as you add the two bases together first, as long as you eventually divide by 2, and as long as you eventually multiply by the height, you should be okay. So that's the basic area questions on the back side. There are some more advanced area questions. So the first one is about finding the area of a regular polygon. So as we learn in class, the regular polygon is simply a polygon where all the sides are the same. So that means that if this side here is 14, every single side is also 14. So all those sides there are 14 as well. So a regular polygon is all equal sides and also all equal angles, but that really doesn't impact our area here. So we want to find the area of this entire shape, and it's going to be a problem because we don't have a formula for the area of this shape. It's not a triangle, it's not a trapezoid, it's not a rectangle, it's not a parallelogram, it's nothing that we've done before. But there is a piece of what we've done before inside it. So if I take this little, what's called the apothem here, the 26.1, I can make a triangle out of that actually. I can make a triangle out of that. So I do have a shape I've done before inside here, and I can figure out the area of that shape if I'm not mistaken. So the area of this triangle right here, again, the area is base times height divided by 2. Well, the base here is at 14. The height is that up and down line, so that's going to be 26.1. Then divide that by 2. So again, if you do some quick math here, 14 times 26.1 will give you 365.4. You cut that in half, and you get 182.7 feet squared, obviously. So that is the area of one triangle. That is the area of one of those triangles. But if I notice here, since everything is the same in a regular polygon, that means that triangle is also right here. That's the same triangle. And that's the same triangle. And that's the same triangle. And so is that, and so is that, and so is that, and so is that, and so is that. They're all the same triangle. So I just simply need to count how many of these triangles do I have. Well, I have one right here, then 2, 3, 4, 5, 6, 7, 8, 9, 10. Basically one for each side. I have one triangle for every side. So if I want the area, I'm going to take the area of one triangle that I got here, which is 187.2, or sorry, 182.7, and I'm going to multiply it by the number of sides, which in this case is 10. So again, 10 here is the number of sides. And that will give me the area of the entire shape, which is 1,827 feet squared. So this boils down to find the area of one triangle that's inside the shape and then multiply it by however many sides there are, because that's how many triangles would fit inside there. So it's kind of a way of cutting the shape up into pieces that you know how to do and then putting them back together to get your final area. So you can't do the area of the entire thing. We don't know that right now. But we can do the area of a small piece and then apply it to every single side and get the area that way. So it's kind of a roundabout way of doing the area. And then the last sort of area problem here is a composite area problem. So it's a problem where the area is involving two shapes that are kind of linked together. So once again, this shape in total is kind of a weird shape. I don't know what to do for the area of it, but I can still get the area by taking it piece by piece like I did with the polygon, which, by the way, this is what that's called. This is a polygon here. So a polygon is simply a shape for all intents and purposes. There's a little bit more rules than that, but we'll just call it a shape. So to get the area of the shape, I'm going to cut it into two separate pieces. I'm going to have the rectangle piece right here. I'm going to have the triangle piece right here. I'm going to find the area of each piece separately and then put them back together at the end. So we'll start with the rectangle because it's going to be easier. So this rectangle is 8 by 5. So the area is base times height, or length times width, and I get 40. Well, that was simple enough. What about this triangle here? This triangle has a base of 5 and also a height of 5. And the reason I know that that's the height is because there's a right angle mark right there. So a right angle mark usually tells you where your height is, especially in a triangle. So that right angle mark is right next to that 5 centimeter line, so that's going to be my height. Also, the height simply tells you how tall the shape is, and that line there is pretty specific on telling me how tall that shape is. So I would do base times height divided by 2. Again, that dot there is a multiplication, not a decimal point. So it's going to be 25 divided by 2, which is going to give you 12.5. So that's the area of the triangle part. So if I want the area of everything, I'm going to take the rectangle area plus the triangle area and get 52.5 square centimeters. That is my total area for the entire shape. So these last two area problems here were a little bit more advanced because they required you to actually piece apart the shape and do this stuff separately and then put them back together only at the very end. The last one here is more of a graphical area question. It's not too terribly difficult compared to the other ones we've had, but it still can throw a trick here and there. So we simply want to make a rectangle given these points. Okay. Well, we have 3 of the corners, and we're missing the 4th one. Well, let's plot the 3 corners we have. So A is at -4, -3. So -4, which is right there, down to -3. So that right there, that'd be A. -4, -3. B is 7, -3. So over 7, down 3. That's right there, that's B. And then C is -4, -8. So over to -4, down to -8. That's right there, that's C. And I want to know where the heck does D have to be in order to make this a rectangle. Let me get this up a little bit. Where does D have to be to get a rectangle? So we want to find out where is the last point here. Well, there's a few ways we can do it. I'll show you a few ways actually. You can simply count how far across some points are, because remember, a rectangle is the same on top and bottom and the same left and right. So the top distance is the same as the bottom distance. The left distance is the same as the right distance. So if I want to make a rectangle here, I can count how far away is A and B. Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 jumps. Let's do C then. So C should be 11 jumps away from D because it has to be the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that would be where point D is, which is at the point 7, -8. If you don't like going across, you can do up and down as well. So for example, A is 1, 2, 3, 4, 5 jumps down to get to C. Well, that means B should be 1, 2, 3, 4, 5 jumps down to get to D. So we get the same point going up and down as well. So you can either count the across distance or you can count the up and down distance. It'll give you the same point either way. And most will be able to just look at it and kind of see where the corner is just by eyeballing it. And if you're unsure, plot the corner, draw the shape by connecting the dots, and see if it looks like a rectangle. If it doesn't look like a rectangle to your liking, then adjust the point. So once again, the goal here is to make sure that you have all the area formulas correct, because if you don't, it's going to have a hard time for the first few questions. And then in addition, knowing how to graph the shapes is good as well. So, hope you enjoy the video. Have a good day.